Hello and good morning to all. I'm Siddharth Jain, studying in BTech CSE third year from Bennett University. Our university not only provides a platform for the students to showcase their skills and talent, but also gives them the motivation to view a world which is full of aspiration. Today, I feel immensely privileged to have this opportunity to present a presentation on the topic cryptocurrencies price prediction using machine learning algorithms. It takes a lot to research upon and study a topic. For that, you need to find the right study for yourself. And for me, it's for this particular topic. The reason being, these models can have significant economic ramifications by helping investors and traders to pinpoint cryptocurrency sales and purchase. To start off, I would like to introduce the topic by saying that predictions are the holy grail of machine intelligence applied to financial markets. Before going ahead, let us see the table of content that we will cover today. So firstly, we will study what is cryptocurrencies. And next, what are the factors affecting cryptocurrencies? In the second part, we will study the benefits and challenges of predictive model of cryptocurrencies and the myths and realities about cryptocurrencies price prediction. In the third part, we will study the different machine learning algorithms used to predict cryptocurrency prices, in which we will cover RNN, linear regression, and LSTM. Then in the fourth part, we will study why LSTM is better than RNN and why LSTM is better than linear regression. And lastly, we will study the architecture, the model implementation, and the step-wise procedure of the implementation of LSTM for cryptocurrencies price prediction. And in the last, we will conclude with some of the references. So now we will understand what is cryptocurrency. Cryptocurrencies is any form of currencies that exists digitally or virtually and uses cryptography to secure transaction. Cryptocurrencies doesn't have a central issuing or regulating authority. Instead, using a decentralized system to record transaction and issue new units. Basically, it is a decentralized digital money that is based on blockchain technology and secured by cryptography. It is cheaper and faster money transfer and decentralized system that do not collapse at a single point of failure. The main point of cryptocurrencies is to fix the problems of traditional currencies by putting the power and responsibility in the currency's holder hand. The most popular cryptocurrencies by market capitalization are Bitcoin, Ethereum, Ripple, Stellar, Bitcoin Cash. Other well-known cryptocurrencies include Tezos, EOS, Zcash, etc. Some are similar to Bitcoin, but others are based on different technologies or have new features that allow them to do more than transfer value. Now, there are many factors influencing cryptocurrencies. Some of them are Google Trends, stock market prices, commodity prices, oil prices, social media, credit metrics. Now, there are many benefits and challenges for predictive model of cryptocurrency. First, we will study the benefits and then we will study the challenges. So, benefit includes unique data sources, asymmetrical opportunities to uncover alpha generating strategies. So here, a question arises that what are the alpha generating strategies? So these are the strategies that help in generating excess returns. It has also a benefit of irrational market with massive potential upsides. Now we will see some of the challenges. These include lack of labeled dataset, irrational markets, small and inaccurate datasets, limited non-correlated factors, and black swan events. Now again a question arises, what are the black swan events? So a black swan is an unpredictable event that is beyond what is normally expected of a situation and has a potential severe consequences. Now we will see the myths and realities about cryptocurrencies price prediction. So I have covered 3 myths and the related realities. So the first myth is that a single attribute can predict the price of a crypto asset. But the reality is that most predictions models requires a combination of many factors. The second myth is that a single model can predict the price of a crypto asset across different market conditions. But the reality is that the most models only work under specific market conditions and they tend to overfit for those. The third myth that I have covered is that all characteristics of a crypto assets are captured in price and volume calculation. But the reality is that a blockchain offers a unique insight about cryptocurrencies that are impossible to capture in price and volume models. Now, we will see different machine learning algorithms used to predict cryptocurrency prices. So the first one is RNN. RNN, also called recurrent neural network, are a class of neural network that are helpful in modeling sequences. Linear regression. These are the machine learning algorithms used for supervised learning. Lastly, we will study about LSTM. These are the networks that are capable of learning order dependence and sequence prediction problems. Now we will study in depth about RNN. A recurrent neural network, also called RNN, is a type of artificial neural network which uses sequential data or time series data. These algorithms are generally used for ordinal or temporal algorithms like language translation, speech recognition, etc. They take information from prior inputs to influence the current input and the output. Because of their internal memory, RNNs can remember important things about the input they receive, which allows them to be very precise in predicting what comes next. Now we will study about the depth of linear regression. So it is a statistical method that is used for predictive analysis. Linear regression makes predictions for continuous real or numeric variables such as sales, salary, age, product price, etc. It shows a linear relationship between a dependent variable and one or more independent variables. In regression, we plot a graph between the variables which best fit the given data points. To calculate best fit line linear regression uses a traditional slope-intercept form. Now we will study about LSTM. The full form of LSTM is long short-term memory, which is an advanced version of RNN. It is a sequential network that allows information to persist. It can process not only single data points, but also an entire sequence of data. They are well suited to classifying, processing, and making predictions based on time series. LSTM were developed to deal with vanishing gradient problems. Now, a question arises that what are the vanishing gradient problems? So, the term vanishing gradients refers to the fact that there is a feed-forward network, also called FFN. The back-propagated error signal typically decreases or increases exponentially as a function of the distance from the final layer. Now, we will study why LSTM is better than RNN. That is, why long-term memory is better than the recurrent neural network. The first reason is that RNN has a long-term dependency. They consider both previous and present input to perform the task, but this is not the case with LSTM. The second reason is that LSTM can deal with vanishing gradient problem in depth. And what are the vanishing gradient problems? We have studied this in the previous slide. The third point is that LSTM can handle the information in memory for the long period of time as compared to RNN. That is the recurrent neural network. Now we will study 3 points that will show that why LSTM is better than linear regression. The first one is that LSTM have higher R2 score, they have low mean square error and much lower maximum error. You will be confused that what are R2 scores, low mean square error or maximum error. We will study in the later part of this slide. Second point is that linear regression is sensitive to outliers, and this is not the case with LSTM. Third point is that long short-term memory algorithms can deal with large set of data, but linear regression cannot. This is the data which I have put in the table, which shows that it has large LSTM have larger, higher R2 score. They have low mean square error, and they have also lower maximum error. Now we will study about the R2 score, the mean square error, and the max error. So what is an R2 score? It is an amount of the variation in the output dependent attribute, which is predictable from the input independent variables. What is a mean square error? A mean square error is the average square difference between the observed and the predicted value. What are the max error? So the max error matrix is the worst case error between the predictive value and the true value. Now we will study about the architecture of LSTM. So LSTM network is comprised of different memory blocks called cells. There are two states that have been transferred to the next state, the cell state and the hidden state. Memory blocks are responsible for remembering the things. Manipulations of the memory in the LSTM is done through three major mechanisms called gates. These includes the forget gate, the input gate, and the output. Now we will study in depth about the forget gate, input gate, and output. So first, we will take about the forget gate. A forget gate is required for removing information from the cell state. This gate takes in two inputs. Second is the input gate. The input gate is responsible for the addition of information to the cell state. Now, the output gate. Job of selecting useful information from the current cell state and showing it as output is done via the output gate. Now, this is the model implementation of LSTM for cryptocurrency price prediction. We will study this implementation using the stepwise procedures in the next slide. This is the stepwise procedure for the model implementation of LSTM for cryptocurrency price prediction. It includes 4 steps: the dataset preparation, the import libraries, build the model and feed the data, and lastly, train and validate. So in the dataset preparation, we collect the raw data, we identify the features, we label the sources, then we select the sampling, and then we lastly split the data. In the second step, we import the libraries. An import library file contains the information that linkers need to resolve external references to export DLL functionals. In the third step, we will build the model and feed the data. In the last step, training and validation is done. A training set includes a set of examples used for learning, that is to fit the parameters of the classifier. And in the validation set, a set of examples used to tune the parameters of the classifier are included. So now from the presentation, following conclusions can be made. Firstly, Bitcoin's grand strategy rests on the idea that as more forks of Bitcoin occurs, the value of each fork will rise. The more forks Bitcoin has, the more people will attract to them. Second, the cryptocurrencies industry as a whole is barely a decade old, and the history of cryptocurrencies is full of cautionary faults. It is observed that cryptocurrencies are far more accurate than LSTM and RNN and linear regression. So in the previous slide, we have studied that cryptocurrency price prediction using LSTM is much better than RNN, that is the recurrent neural network, and the linear regression. Before, overall, given the diversity of influences influencing the market, predicting a cryptocurrency related variable is challenging. These are some of the references that I have taken for my help. With this, we came to an end of the presentation. I hope there were a lot of new things that you all learned from this presentation or this video. And there was a vastity of learning that happened through my study. The importance of this topic will slowly and steadily rise with time. We need to understand its utility with time speed. I would like to thank my faculty and the university and my professors who have always motivated me to achieve the most of what I can do. This presentation wouldn't be possible without them. Thank you.